Hello students, good morning all of you. This is your Prabhakar and welcome to our channel Dawn of Chemistry. Right. In this video, we are going to discuss about the Vesper Theory. What is this Vesper Theory and what is the significance of this Vesper Theory and how to identify the structure of any molecule by using this Vesper Theory. See, for many of the students, it is a very difficult task and nightmare to understand the structure of any molecule by using this Vesper Theory. In this Vesper Theory, there is a bigger table where it will be telling 2 lone pairs, 1 lone pair, 3 lone pairs, 3 lone pairs, and AB2E molecules, AB2E2 molecules, AB3E molecules. Sir, I am fed up of all these things. Sir, how to identify what is the type of molecule, how many lone pairs are present in a molecule, and what is the hybridization of the molecule, how many bond pairs are present in a molecule. In my previous video, I have explained you how to identify a number of lone pairs and bond pairs in that thing, so you can check for that thing. In this video, directly I will be explaining the Vesper Theory, how they will be asking you the questions based on the different examples. Mostly, whatever the inorganic compound we are getting in +1 and +2, the total things structure simply you can explain by using this Vesper Theory. There is no need to by heart the structure and don't worry about that thing. So wait, let's get into the topic Vesper Theory. This Vesper Theory is extension of hybridization. According to this Vesper Theory, valence shell electron pair repulsion. Valence shell electron pair repulsion theory. Basically, by using the hybridization, we can identify the structure of any molecule. But there are some molecules which you can't explain the structure by using the hybridization. What are those molecules? Means H2O, NH3, XeF6, XeF2, XeF4, SF4 and XeO3, and like this we are having number of compounds. When the examples are coming, that time I will give you the clear data about these things, PCl3 and all. Like this there are so many compounds by using with which hybridization you can't explain the structure of these molecules. To explain the structure of these molecules, a little extension was made for this hybridization, that is nothing but the Vesper Theory. So according to the Vesper Theory, every atom will have 2 types of electron pairs. What are the 2 types of electron pairs? Means bond pairs and then lone pairs. Bond pairs and then lone pairs. So every molecule will be having the bond pairs and then lone pairs. In my previous video, I have explained how to identify the bond pairs and then lone pairs. If you look at the formulas, number of lone pairs is equals to number of hybrid orbitals minus number of bond pairs. So number of lone pairs is equals to number of hybrid orbitals minus bond pairs will be coming. If you want, number of bond pairs is equals to number of atoms surrounding central atom. So number of atoms surrounding the central atom is nothing but number of bond pairs. Number of lone pairs is nothing but number of hybrid orbitals minus number of bond pairs. We can find the number of hybrid orbitals simply by finding the half into V plus M minus C plus C. You can refer to the solving problems in hybridization in 10 seconds part 1. You can identify this formula. So let us get into the topic. So what is these things means? According to Vesper theory, the bond pairs and lone pairs present in the molecule will always repel one another, because electrons are nothing but negative charges. When negative charges are present side by side, there will be so much repulsion between them. So to overcome those repulsions, they will arrange themselves around the central atom in such a way that the repulsions will be minimum. If you observe these lone pairs, lone pair repulsions are stronger than lone pair bond pair repulsions are stronger than bond pair repulsion. This is a very important statement. For your NEET exams, directly they can ask you the questions. Even for state entrance examinations also, they can give you the direct question. Arrange the following repulsions between the lone pairs, bond pairs and lone pair bond pairs in the increasing order of them or in the decreasing order of them. Always remember, lone pair repulsions are stronger than lone pair bond pair repulsions are stronger than bond pair repulsion. So atoms around the central atom arrange in such a way that the repulsions between them will be minimum. So that's why they will be having the different structures. So now let us get into the things. Whenever there is sp2 hybridization, AB3 molecule is possible. Whenever there is sp2 hybridization, AB3 molecule is possible. Here I will represent, see, A as central atom and B as bond pairs and E as lone pairs. So everywhere I will be representing this only. So try to go through this thing. So sp2 hybridization is there, means the molecule is AB3. So here 3 bond pairs are there and there is no problem with any lone pair. So that's why structure is, you know very well, sp2 hybridization means it will be trigonal planar structure or planar triangle structure. The examples we are having is BH3, B of 3, BCl3 and then BR3. Like that we can have so many compounds. Let us see, if in place of one bond pair a lone pair is coming, AB2E. Let us see, AB2E is there, means the central atom is A and one is B and one is B. In place of one B, here AB3 you can have A is in the center, B and B. So A is present in the center and B's are occupying the corners of a triangle and hence it will be trigonal planar. In place of one bond pair, one lone pair is coming. So that's why one of the bond pair is replaced with the lone pair. Since it is replaced with the lone pair, there will be repulsion between this lone pair and between the atoms. Maximum repulsions will be present and hence its shape will become bent shape. So its shape will become bent shape or V shape will come. So the shape of this molecule will be bent shape or V shape will be coming. Like this we can understand this AB2 molecule. Next go to the sp3 hybridization. Whenever it is present in the sp3 hybridization, the molecule we can have is AB4 molecule. AB4 molecule means it is tetrahedral structure it will have. Tetrahedral structure means examples you can have CH4, CCl4, SiCl4. Like that you can have number of examples where A is in the center, B is above, B is bottom. So 3 atoms will be present like pyramid and 1 atom will be above the plane. So that's why 3 will be there and they will be forming the base of a pyramid. 1 atom will be above and which gives you a tetrahedral structure. So now you see, if one of the bond pair is replaced by lone pair AB3E, then it will be having. So here in this molecule A is in the center. Always remember, axial lone pair or axial bond pair will be converted into the lone pair. So in this case axial lone pair will be converted into the lone pair. So since Three atoms are like pyramid and one is there. So here now this atom is not there, only lone pair is there. So what shape you are getting here? Pyramid shape is there. That's why the structure of this molecule is pyramidal structure. Example for this thing is NH3 and then PCl3 will be coming. Like this we can have the structure. Here in place of another bond pair we will substitute one more lone pair. So it will become AB2E2. So it is becoming AB2E2 means what is coming? Here 3 bond pairs and 1 lone pair is there. Here 2 bond pairs and then 2 lone pairs are there. Since 2 bond pairs and 2 lone pairs means A. Above 1 lone pair will be there and here 1 lone pair will be present. B and B will be there. So if you observe here, the repulsion between the lone pairs will be maximum and hence they will move away from one another and they will be forming a bent shape will be coming. So they will form bent shape or V shape will come. So like this we can understand the structures for the molecules having sp2 hybridization and then sp3 hybridization, how to replace the bond pair with the lone pair and where we have to replace. Since it is trigonal planar, you can replace the bond pair from any side, it doesn't affect the structure. But in this case, definitely you have to remove the structures from these things, then only it will be possible for us. So like this we can understand. The best example for this will be carbene will come. Carbene structure, it will be CCl2 with a lone pair will be coming. So CCl2 is the best example for this. sp2 hybridization with a lone pair. Like this we can study about for sp2 hybridization how many structures are possible with lone pairs. For sp3 hybridization how many structures are possible with the lone pairs. You can have examples for this one, bent shape. You can have examples like H2O, H2S, H2Se and then H2Te, hydrides of the oxygen family. You can have them as best examples for this thing. So that is about the for sp2 hybridization, what are the structures possible with the lone pairs, and for sp3 hybridization, what are the structures possible with the lone pairs. Right. Take down this thing. Hope all of you are enjoying learning from this channel. If you like the video means like the video button or click the like button so that it will increase my enthusiasm to create some more interesting videos for you people. If you like this video means you can share this with your friends by clicking the share button. To get more updates from my channel, subscribe to my channel. Right. Let us see, after sp3 hybridization we will go to the sp3 dehybridization. So what is this sp3 dehybridization and how lone pairs are possible and what are the positions taken by them? Listen to this one. This is very important thing because so many molecules of complicated structure are based on this sp3 dehybridization. Whenever the hybridization is sp3 dehybridization, the molecule will be of AB5 type. AB5 type means it is trigonal bipyramidal will come. So since it is trigonal bipyramidal ABB, so they will form a triangle in the base and one B will be present in the axial position and another B will be present in the equatorial. So when you take like this, A is in the center, 1, 2, 3. B's will be like this, one B will be down and one B will be top. So since it is a triangular base with one axial position, it looks like a pyramid, and top one pyramid is there and bottom one pyramid is there. That's why we call it as a trigonal bipyramidal. Now you see the different molecules possible for this thing is, example is PCl5 will be coming and PBr5 also will be coming. AB5. This is in gas phase. You know very well in solid state what is the structure of that thing. AB5. Replace one of the bond pair with lone pair. So always remember, in this case it will occupy equatorial position. Lone pair occupy equatorial position. This is a very important thing. Only in case of sp3 dehybridization only, lone pair prefers to occupy equatorial position first thing. In this case it will prefer to occupy the axial positions only, preferably. So AB4E means A will be in the center, B and B. So if you observe this structure, here on the equatorial position, lone pair is coming. So since there is equatorial position, lone pair is there, the structure is not proper. So we call this structure as seesaw structure. So seesaw structure, and the best example will be SF4 and then SCl4 are the best examples for the AB4E molecule. And next you see here, replace one of the bond pair with the lone pair, AB3E2 molecule. AB3E2 molecule means A, B will be present here. One lone pair comes onto this position and one lone pair comes onto this position. So they will be forming this equatorial position. Axial 1B will be there and one more axial B. If you observe this, how it looks like, it is like T structure, right? So since it looks like T structure, the shape of the molecule will become T shape will be coming. The best example for this T shape molecule is ICl3 and then IBr3 will be coming, or ClF3. So these molecules are examples for the T-shaped molecules. In this case, how many bond pairs? Bond pairs are 3 and lone pairs are 2. Here bond pairs are 4 and lone pairs are 1 will be coming. And next we will go into the another category, AB2E3, where bond pairs are 2 and lone pairs are 3 are there. So let us see the structure. In AB2E3, A is present in the center, lone pair occupies equatorial position and then equatorial positions, but the bond pairs are occupying the axial position. Since bond pairs are occupying the axial position, the structure of the molecule will become linear structure. The best example for this thing is XeF2. This is a very important thing. So like this, with sp3 dehybridization, the lone pairs, whenever we are replacing every lone pair, every bond pair with a lone pair, it will be occupying the equatorial positions, and gradually they will occupy all possible equatorial positions and they will be producing the different structures. So like this, with sp3 dehybridization, we can form the different structures. So let them give you any molecule. I told you how to find the number of hybrid orbitals by using the formula half into V plus M minus C plus A, and how to find the lone pair electrons means it will be like number of lone pairs is equals to number of hybrid orbitals minus number of bond pairs will be coming. How to find number of bond pairs means whatever the atoms are surrounding. Here SF4, how many bond pairs means 4 bond pairs. SCl4 means 4 bond pairs. XeF2 means 2 bond pairs. Like that, easily you can understand the how to identify the bond pairs. Now let us get into the other hybridization. The other hybridization we are having is sp3d hybridization. So how to do this thing? By this sp3d2 hybridization. Whenever there is sp3d2 hybridization, we are having AB6 molecule, which is a octahedral or the other name for this one will be square bipyramidal. Here you see trigonal bipyramidal. Why? There is a triangular base and above one B will be there and below one B will be there. That's why we call it as a trigonal bipyramidal. Here why we call it as square bipyramidal means A is present in the center, B is present in the corners of a square, one B will be above the plane and one B will be below the plane. So for sp3d2 hybridization, whenever you are putting the lone pairs, remember they occupy axial positions only. They occupy axial positions first and after that they will go to the equatorial. But with equatorial positions, lone pairs we are having very less. So we preferably go with the axial position examples only. The best example for this thing is SF6 will be coming. So this is the major example. Let us go to the other category, EB5E, where 5 bond pairs are there and 1 lone pair is there. And another one will be EB4E2, where 4 bond pairs are there and 2 lone pairs are present. So see, whenever there is, as I told you, the lone pair will occupy the axial positions and hence you can write the structure as A, B, B, B. So all B's will be 4 corners of the square and 1 B will be below this one. And you see here, the lone pair will occupy the axial. So here you see this is square bipyramidal. Above one pyramid is coming and below one pyramid is coming. But in this case only above lone pair is there. So it comes to below. So we call it as square pyramidal. Square pyramidal we call it as. So like this we can have this thing. Example for this thing will be XeO F4 will be coming. So see, in the inert gases compounds, xenon oxides, xenon fluorides and then xenon oxyfluorides, there only we will be using all these things in the major position. Oxygen occupies the axial position. Like this we can have. And one more thing you can have is ICl5 also you can have. Iodine pentachloride also will be having the same structure. Now let us go to AB4E2. Since A is present in the center, B's are present in the corners of a square, the lone pairs will be occupying the axial positions. One lone pair is above and one lone pair. What structure you can see here means it is a square planar will come. So since it is square planar, the best example is XeF4 is the best example for this kind of structure. So like this we can identify. These are the major examples we are having, and beyond this thing we will not be having any other models in our NCERT or even for competitive exams also, even to the advanced extent also, only up to this much models only they will be asking you. So in sp3d2 hybridization, to this extent only we can have the problems. See, in this case how many bond pairs will, since 4 atoms are attached to the central atom, always remember only one atom will be present as a central atom. Next, let us see the sp3d3 hybridization. What are the different structures possible for the sp3d3 hybridization? Let us see sp3d3. sp3d3 hybridization, the example molecule is AB7. In this AB7, A is present in the center, B atoms are present in the corners of a pentagon. So a pentagon is formed at the corners and one atom will be above the plane and one atom will be below the plane. The structure will be pentagonal bipyramidal. The best example will be IF7 is the best example. Iodine heptafluoride is example for this thing. And we are having only one compound with lone pair, means beyond this thing we will not study any other things. That's why it will be AB6E with 6 bond pairs and one lone pair is present. So this lone pair will be occupying equatorial position. Lone pair occupies equatorial position. So since lone pair occupies the equatorial position, the structure will become A, B, B, B. Axial B will be there and below axial also B will be there, and the lone pair occupies the equatorial position. So if you look at this thing, since there is a lone pair and 4 atoms are present in the plane, so it's looking like if this lone pair is not there, means it will be octahedral, but this lone pair is there, that octahedron will be little distorted and the structure will become distorted octahedral. So distorted octahedral structure will come. The best example will be XeF6 will be coming. 6 bond pairs are there and 7 hydroid orbitals are there and 1 lone pair is present. So like this we can understand the different compounds, and based on the structure and based on the lone pairs available on them, we can have the different examples for this Vesper theory. This is very important one, man. If you take for example halogens, we can have so many interhalogen compounds are there. Those interhalogen compounds are of type XX dash, XX3 dash, XX5 dash and XX7 dash are there. So the best example for these things, what is the structure of them means mostly you will be by hearting all those things. Actually there is no need to by heart the structures. XX dash means ICL, CLF, BR, CL and BRF. Always X dash is a small atom and X is the large atom. So then only those compound will be existing. There is a table also in your NCERT textbook based on this thing. So what is the structure of this one means ICL. The hybridization in ICL will be, I am explaining this here. ICL hybridization is sp3. 7 plus 1 by 2, 4 will come. So the hybrid orbitals are 4 are there. So here 3 lone pairs are there and 1 bond pair. Chlorine is there, so it is bond pair. And hence it is a linear molecule. So iodine will be like this. Chlorine will be like this and 3 lone pairs will be present. And XX3 dash means you can have ICL3 or IBR3, where it will be having 3 bond pairs and 2 lone pairs and they will have T shape. ICL5 you can have where 5 bond pairs are there and 1 lone pair is present. So it will be having what structure? sp3d hybridization or sp3d2. Here 7 plus 5, so sp3 D2 hybridization. So it will be having square pyramidal structure, and finally IF7, there is no lone pair at all, so pentagonal bipyramidal. Like that, writing the structure of interhalogen compounds, definitely you will be having dependency on this Vesper theory. When you take inert gases compounds like XeF4, XeF6 and all. So let us see the inert gas compounds we are having is XeF6, XeF4, XeF2, which are the fluorides. Oxides of xenon are XeO4 and then XeO3. Oxyfluorides are XeOF4, XeO2F2, XeOF2. These are the xenon oxyfluorides. So what are the structures of these things means we will be depending upon this Vesper theory and we will be identifying. And sulfur halides are there, sulfur hexahalides are there, sulfur tetrahalides are there. That is oxygen family halides. When you go to the carbon family halides means there is no chance for the lone pairs in the carbon family halides especially. And nitrogen family halides we are having PCl3 and PCl5, like that number of compounds, whatever the structure is there, by using hybridization and by using Vesper theory, without by hearting anything, you can identify the structure. So if you see, for example, XeO2F2, for XeO2F2 the hybridization is sp3 dehybridization. Since 4 bond pairs are there, 1 lone pair is there, the structure will be seesaw structure will be present, like this. By finding simply bond pairs and lone pairs and hybridization, by using the techniques I am explaining, you can write the structure of any compound they are giving you. Don't worry ma, for coordination compounds there is no chance of formation of lone pair, so that's why there is no much complication about that thing. So that is the thing regarding this Vesper theory. Hope you are understanding this concept, and thank you.